Hello and welcome to our ECE 492 Capstone Design Project's final presentation and demo. We are Jarrod, Ryan, Vanika, and Zach, and our project is Equine Surface Temperature System. Horses are prone to multiple joint-related conditions that develop over time as a result of strain or even due to old age. These ailments can be indicated by unusually high temperatures of the horse's joint. Unfortunately, a late diagnosis on some of these conditions can cost thousands of dollars in bills. The professionals in the industry usually feel the joints by wrapping their hands around the joints, so the existing diagnostic tools are either not so accurate or they're complex, expensive, and hard to use in a field environment. This inspired us to create Equine Thermal Glove, which is a wearable device used to measure temperature of a horse's limb joints before and after workout to produce a diagnosis on joint health. It is an affordable and easily applicable system that not only measures thermal data from a horse's joints, but also processes the data to obtain a visual analysis of the diagnosis. The glove can be paired to the ETG smartphone application on an Android phone, upon which temperature measurement and transmission process can begin. Our client for this project is Dr. Stephen Knudsen. We also want to take this opportunity to thank our technical advisors, Dr. Knudsen and Raju. We will now show you a demo of our project.
Taking a look at our hardware, we first see that there's a sheet of cardboard which serves as structural support, and on top of that is mounted most of our circuit, our board, and our battery. Now, taking a look at the board and battery in particular, we can see that it currently has a USB and a battery connected. In this state, the USB will take precedence and actually recharge our battery and power the board itself. And it has a nice functionality where you can actually unplug the USB and it will remain still fully functional and is called a hot swap. Looking further on our board, we can see the use of 5 analog to digital converters, one for each thermistor in the tip of each finger, a common ground, and power. Now behind this electrical tape is a 10K resistor in series with our approximately 10K varying thermistor. And with a change in temperature, there will be a change in resistance in our thermistors. And this particular circuit creates a voltage divider such that our analog to digital converter can read this voltage between the two resistors and correlate that to a change in temperature on our board. Now all of this has been insulated with electrical tape, providing structural integrity and also preventing any shorts due to the open circuitry. We also see that there's enough slack on each finger, which will be later demoed, such that you can actually grasp the horse's joint or even squeeze your fist without too much strain, if any, on the circuit. Now flipping it around to take a look at our actual thermistors, we can see that there's one embedded in each tip of each finger, one for each analog to digital converter, which concludes our examination of hardware.
When loading the app for the first time, you will be prompted to log in or register. You cannot register with an invalid email or a non-existent email, and you can also not register with a already existing email. You will also be unable to sign in with a non-registered email. From here, we can sign in with a registered email and proper password. After successfully logging into the ETG app, you'll be shown two new buttons, the Start Connection button and the View Existing Data button. If we click on the Start Connection button, a new activity will be brought up that searches for and displays the ETG Glove's Bluetooth string. You can also click the Refresh button if the string does not appear. Unfortunately, since only one group member has the glove, this portion of the app's workflow will not be demonstrated now, but will be demonstrated in a later portion of this demo. The other button shown after successfully logging in is the View Existing Data button. If you click on this button, a new activity will be brought up, which will display all the horses that are registered to your account. From here, we can also choose each limb. In this case, we'll start by choosing the front left limb, and we will choose horse 2. Now 2 new buttons have been shown. The Delete Data button, which will completely delete the data from the database, as well as the View Data Graph, which will show all previous data as averages. Here we will click on the View Data Graph button. As we can see, there is only one measurement. We will now return and show a limb with more measurements. So from here we can choose the back left, and we will choose to View Data Graph again. From here we can see 2 different measurements. We can see the first measurement, say before a workout, to get a healthy temperature range. This first bar is in green to show that it is where it is an acceptable temperature range. In the second bar, this red bar, we could assume would be after a workout. This could be an indication of a potential illness for the horse, as it is above the acceptable threshold, which is this red horizontal bar here. The blue horizontal bar is the minimum threshold. Anything below that, a bar will be blue. From here we can return, and we will show deleting horse data. So we will click on horse test empty, we will click on delete data. Now as we can see, the horse is completely gone. It is no longer part of the database.
So now that we've looked at both the hardware and software, we will now look at the integration of the two. So we already signed in, and we'll connect to the glove by hitting Start Connection. We can refresh and see which devices are available. We see here near the bottom the Equine thermal glove. By selecting it, it will connect and signal to the glove to start taking measurements and transmit that via Bluetooth back to our app. This is approximately the ambient temperature in my room. And now I will do a demo with my arm to show the increase in temperature. So taking a look at the app, we will see that it periodically updates. One problem that we discovered with the app was the latency in the thermistor's ability to essentially warm up. That is to say, the accuracy is not an issue, but the time it takes to actually heat up the thermistor and get the change in resistance to reflect the level of accuracy that we desire, that is to say approximately 35 degrees for the average human arm, will take about 3 to 4 minutes with the thermistors that we currently use. In future work, we would have to do further research into new thermistors to reduce this time to about closer to 20 seconds. Moving on to the measurements, we see it's about 31, 32, which is pretty good. Again, it would take a couple minutes to get that extra, but let's, for the sake of this, take the demo here for our constraint on time. So, removing the glove, saving the measurement, we can now see that it's reflected on the data. So we'll save this to a horse's name. So let's say it's going to be Jarrod. I suppose it seems reasonable, and that was my front right arm. So we're going to save, return to main menu, view existing data. We're going to select Jarrod as our horse. Then we're going to select our front right limb, view data, and we can see that I am indeed in a good range to be for resting as a horse.
Lastly, we'd like to talk about some future work and future goals and continuation of this project. Things that we'd maybe go back and change or we didn't have time to get to. Firstly, we'd like to switch our MCU from the Atmega 23U4 to something like the MDBT40 module. It's pre-certified, it uses the same NRF chip, gets rid of a lot of unused components, it's cheaper, and it's basically a minimal Bluetooth design. We'd like to also refactor the ETG application a little bit, follow a more structured model view controller setup, provide support for iOS, and add some ease of life changes. We'd also like to expand the trend analysis module, add some filtering dates to certain ranges, min-max measurements from those ranges, swap between days and compare all the measurements from a certain day. perhaps a compare horses and limbs component, and provides hopefully some baseline for horse measurements that can lead to some kind of machine learning applications. And last thing we'd like to look at is the glove. We'd like to get a more waterproof material, add a pouch to the top of the glove for the components, which makes them more contained, but also easily accessible, and perhaps look at a better fitting glove. In conclusion, our biggest challenges were the time we had to complete this project and the isolated work environment. But despite that, we did realize our walking skeleton from our client's concept. We've provided something that they can take forward and build off of if they desire. Lastly, we've acknowledged some future work and goals to improve the equine surface temperature system.